Hello, good morning, Sachin. Sachin, hello.
Hello, sir. Hello. Hello.
Good morning, Darshan.
Good morning, sir. Sir,
Darshan, good morning.
can you
Am I
switch off
audible?
the recording?
Ah,
Yes, sir, you are
yeah,
audible. But can you switch off the recording because people
audible, no?
are unable to join when it's up to 10.
No, no, people, they are getting admitted because I cannot, switch off the recording because that is our requirement. We have received the
Sir,
instructions
for
from the
5 minutes,
director and principal that
after 10,
because the
5 or
session, no, but people are getting admitted, no? Absolutely, there is no problem. Huh?
okay, sir.
There is no problem.
Good morning, sir.
Yeah, yeah. Good morning. People are coming in, so why to stop recording? And there was a request, from one of the students to share the recording, but I asked the HOD, but he said not to share the link. I don't know. Some faculty they are sharing, but since I received the instruction from the HOD, so that's why I'm unable to share the link. But however, I am sharing all the PPTs and study material.
Yes, sir.
And in case if you have any doubt, you can always ask me. You can WhatsApp me on my number, or you can ask in classroom as well. I'll just wait for few minutes because students are joining. Otherwise, once if I start, no, then again there will be a problem. Somebody has to mute it. So this is what we are discussing. How to, we are discussing CNC hardware on Monday. That is last lecture. So these are some parameters which will be helpful for you for designing. And I will tell you, the design of CNC machine is really very beautiful to learn as well as to design the machines. So what are the different design criteria and machine response? How fast your machine response will be? Type of the command signal. Type of the command signal means whether you are giving a square pulse or whether you are triggering a triangular pulse. Then what is the maximum feed rate you want? Then what should be the static accuracy, dynamic accuracy? Dynamic accuracy means when you are considering the forces. What should be the load, that is the weight of the component and range of the travel. So I think you can understand this all very well. Mm, Power requirement, friction characteristics. Nowadays we are talking about frictionless movement. We are talking about frictionless movement. So for that, we consider a kind of a coating uh, where the coefficient of friction is zero. That
हॅलो
is
सर.
Hello,
value of
sir.
mu. Yeah, yeah.
तुमच्या आवाजात खूप
Yes, please.
डिस्टर्बन्स आहे. तुमच्या आवाजात खूप डिस्टर्बन्स आहे.
आवाज नाही येते सर
Disturbance आहे.
प्रॉपर. हो
खूप
सर.
डिस्टर्बन्स आहे सर. खरखर होतो एकदम आवाज.
नाही ते कोणाचं तरी तिकडे हे असणार, चालू असणार बॅकग्राऊंड मध्ये.
नाही
नाही
सर,
सर
आता
दिसत
येतोय
तर
का?
नाहीये सध्या.
म्यूटवर सगळे म्यूटवर आहेत
हॅलो,
सर. तुमच्या याच्यात सगळे
हॅलो.
म्यूटवर आहेत सर. हॅलो सर.
आता येतोय
हॅलो.
का?
नाही
हॅलो.
सर, ते
नाही
खरखर
सर
होतो
अजून
एकदम
नाही
आवाज
येते.
तुमचा.
I don't know why.
एकदम डिस्टर्बन्स येतो सर आवाजात तुमच्या.
Wait, let me check. Let me check. It should not happen actually. I don't know why it is. Let me check. Hello. Yeah, Sachin. Now I am audible properly. Hello.
Yes, sir, you're audible.
Yeah. Yeah. So most of the parameters you are aware, like what is your budget, that is capital investment, reliability, then maintainability, that is whatever you design should be maintainable. So these are the few parameters which are to be considered when you are designing a CNC machine tool. Now what you are seeing is that is bed, and we are providing a foundation, that is a cement concrete foundation over here. This is a foundation, and this is what is your cast structure is, and this bed is inclined. Why we incline the bed? First thing is that it offers a good rigidity to the machine tool, and second thing is disposal of the chips and the coolant. The chips and coolant gets disposed very easily. What CNC lathe we have in our college is inclined. Usually angle of inclination is 30 degree to the vertical. These are the vibration characteristics which are studied for different foundation material. Spindle is most important in any CNC machine, spindle design, because on the spindle we are holding a component or we are holding a job. So spindle should transmit the torque as well as power properly so that component can be cut very easily. Of course, there should not be any vibrations, there should not be any chatters on the workpiece. This is what is your spindle is, and this is a hollow spindle machine tool. Hollow spindle means it has a bore. This is what is your bore is. This is the wall thickness of the spindle. This this is obviously your headstock, and spindle is mounted in the bearings. So you have two bearings at the ends. These bearings are roller bearings, and this is your ball bearing. So selection of the bearing depends what kind of load the spindle is going to carry, whether it's a radial load or whether it's a axial load. Like when you are doing OD turning, you get axial load that is also called as the thrust, and when you are doing facing, then that time there is a radial load. So accordingly, your bearing has to be selected. So this is what forces are: two forces. It is axial force and the radial force. If the speeds are very high on the machines, that is, we are talking about say 10,000 or 15,000 RPM, then lot of heat is generated. So you have to design. This is what we are considering all the design parameters. So you have to design your machine in such a way that heat has to be dissipated. So there has to be a cooling arrangement, a proper cooling arrangement, either oil cooling or chilling. Chilling means water cooling. So you need to have some chillers also outside your CNC machines. And even for oil cooling also, you need to have chilling unit. So whenever you are purchasing as a purchase engineer, you have to consider the cost of the accessories also. You should not focus only on CNC machine. Yes, CNC machine that contributes the major cost. But along with that, you have to consider other factors also, like environmental conditions, that is cabin, the room, it should be vibration proof, it should be AC, there should be proper humidity, then chilling unit, then conveying unit. So all this uh, has to be considered in the budget, and you have to give the proposal to the management. Otherwise, your boss may scold. अरे अभी 15 लाख का मशीन लिया, अभी तुम और बोल रहे हैं कि 1 लाख का चिलिंग यूनिट डालने का है, पहला क्यों नहीं बोला? So like that things happen. So doesn't matter even if you are slightly late, but you must consider all these factors. Then your motor and gearbox also get heated. What machine we have in our college, it can reach up to 6,000 RPM, 6,000 revolutions per minute. And nowadays the machine, nowadays means 10 years back, the machines are available up to 12,000 or 15,000 RPM. We call it the high speed machines. So heat dissipation is very important. This is what a typical spindle will look like, isometric. Earlier you saw the cut section. So you have a provision of cooling. There are water channels. So either a water or oil is circulated continuously so that the heat is not generated. You should have good quality bearings so that your spindle rotates true. Rotates true means it is not moving eccentrically. I hope you understand this. That is, if you put a dial indicator here, a plunger type dial indicator on this surface, look at my arrow, then it should show 00 or maximum deviation is not more than 5 microns. Then only you will get the accuracy of 10 micron or 20 micron on the workpiece. If your spindle itself is running out, then you do not expect any kind of accuracy on the workpiece. So this yellow color, that is what is bearings. And of course, obviously you should have two bearings at the end and one bearing in the middle. You can have L frame construction as well as you can have C frame construction. So see, the design is not that easy. Huh? You have to consider how to cast also. It should be designed for manufacture. You have to design in such a way that it should be manufacturable. Anybody can design, but it should not be complicated. That it cannot be manufactured at all. It's of no use. That design is of no use. So whatever you design, it should be designed for manufacturing. It should be designed for assembly. It should be designed to cost. That is, you should have minimum cost. Then ease of assembly, ease of manufacturing, ease of maintainability. That is maintenance point of view. Maybe maintenance free. Your design should be like earlier bearings. I remember we used to receive open kind of bearings. So every 10 days or every week we need to put grease inside the bearing, open the machines and put the grease. But nowadays bearings you receive in sealed condition, and the bearing manufacturers, they use a good quality of grease. So they put the grease inside the bearing and then seal it. That is for the end shields. They put the end shields from both the sides and they say now this is maintenance free. You don't have to put the grease. So this is what is called the maintainability. So you can go for C type, you can go for L type depending upon what is the weight of the components. You can go for fixed bed or you can go for moving bed. Fixed bed means your bed is fixed. Moving bed means your bed is moving. So obviously if your weight of the component is more, like in case of dies, heavy molds for the automobile bumpers, the mold weight is around 1 ton or 1.5 ton. So obviously that time you'll go for fixed bed type of construction. Fixed bed means the workpiece doesn't move. The head, that is this head, tool head, it that moves in X direction, Y direction, and Z direction. Workpiece is stationary. Because if you want to move this heavy workpiece, 1.5 ton, then obviously your structure will become very heavy. Your HPs of the motor will be very high. Entire design then changes. Your spindle drives, your feed drives has to be very robust. Your braking, your overshooting, undershooting, that has to be considered. So in case of heavy duty machine tools, heavy duty component, you have to go for fixed weights. This is what is your design criteria. Usually one question is asked, what are the different design considerations for CNC machine tools? This is called the bifurcated column in order to improve the torsional rigidity. There are two type of drives which are used in CNC machine. One is your spindle drive and another is feed drive. The purpose of spindle drive is to give the torque to the spindle, the workpiece. In case of lathe, the spindle is rotating. In case of milling, the tool is rotating. So spindle drive means you are rotating your spindle, and another drive is feed drive, that is axis movement, that is x-axis, y-axis, and z-axis. So what are the considerations in spindle drive? Obviously, material removal rate has to be more. Then speed. The beauty of CNC machine is the speeds are infinitely variable. We call it as a PIV, that is positive infinitely variable. So in case of CNC machines, you have speeds ranging from 0 to 12,000. Suppose if 12,000 RPM is the capacity, then you can get any speed in between. Like suppose 500.23. So any decimal point you can get it. Not necessary that you will get only integer value. Alright. Whereas in case of conventional machines, you can get only fixed speeds, 200, 500, 1000, like that. So like infinitely variable speeds, you have infinitely variable feed also. Feed. DC motors are preferable because of maintenance, from maintenance point of view. This is what microprocessor control frequency converters, AC motors are used. There are no commutator and brush. So nowadays the AC motors are better than DC motor if you talk maintenance point of view. Then spindle drive can be used to position the spindle axis. To position the spindle axis means, like suppose if I want to rotate and stop the spindle, you have seen the video. If I want to rotate and stop the spindle at say 110 degree or say 115 degree or maybe say 80.23 degree. So that is possible, and that is what is called as the orientation, spindle orientation. So again, different kind of hardwares are used like DC servo motors, brushless DC servo motors. Like I told you, in AC motors nowadays it is available without brush. So even DC servo motors are available brushless, and every servo motors it has their own advantages. Like DC servo motors, high performance, useful in prime moves. Prime moves means it gives motion on its own. The response is better. Response is better means quick response. This is what you will run in control engineering. There is feedback. Like suppose if I want to apply a brake, then you should have an immediate response. The braking distance should be as less as possible. Otherwise, it is going to hit the person. Understand? No. Suppose if the person is crossing the all of a sudden, a person is crossing the road and you have to stop the car immediately. So the response should be very fast. Like suppose if a teacher is asking a question, then you should respond in as less time as possible. Then the advantages of DC servo motors, brushless DC servo motors, heat dissipations, motor inertia, it reduces. That is, the weight of the motor is less. So we call it as a weight to speed ratio. So this is what the beauty of design or the work of design engineering. Earlier we used to go for stepper motors. Stepper motors you might be using also in your projects. Those who are working on different projects, they might have used stepper motors. The advantage of stepper motors is it's low cost, very simple in construction, good reliability, and maintenance is not required. But the limitation, then why not go for stepper motor? It has limitations. Like suppose if I have same 50 steps in a circle, I have a 50 steps in a circle, or mathematically, if I want to make it simple, if I have 36 steps in one circle in a stepper motor, 36, 36, then every step, that is, if the motor is rotating through one step, how much degree it will rotate? 360 degree divided by 36, so 10 degree. I hope you are getting it. Suppose a stepper motor has 36 steps, so every step, that is rotation of every step, will give you a 10-degree rotation. How do you got it? One revolution is equal to 360 degree. So 360 degree divided by 36, that is 10 degree. If it is 72 steps, then 5 degree, and like that. So suppose if I want 1 degree rotation, then I should have that many steps. So that's the limitation. You cannot have more than 100 steps. So there is a limitation of resolution. Resolution means through how much degree spindle can be rotated. And nowadays we are talking about a resolution of not 1 degree. We are talking about resolution of zero point 0.1 degree, resolution of 0.05 degree. That is, my spindle should rotate through 0.05 degree into 60. That will give you minutes. Into again 60. That will give you seconds. So we are talking about the technology is talking about rotation of the spindle, not only through degree, not only through minutes, but through the seconds, which is not possible by stepper motors. So we have to go for servo motors. There is no option. But of course, if you want to go for low cost solution, then stepper motor is the best. Then right now you may be knowing that motors means always a rotary motion. Not so. You can have linear motors also. So linear motors means what? The output will be reciprocating. Output will be reciprocating. That is, you give a electric supply. This is the cable, and output side will be a reciprocating motion. That is what is linear motors mean. What are the actuation systems? Actuation system means the motions. What are the hardwares or what are the devices which are used for getting motions? One is lead screw. Now, in case of CNC, we don't use a term called as lead screw. We use ball screw, because in ball screw you have zero friction. Slideways, we use linear motion guideways. Linear motion guideways means the slideways. Slideways is nothing but the guideways, means on which your linear movements or longitudinal movements occurs. So these slideways are coated with tersite. Tersite is a kind of a polymer which gives you zero friction. So this offers a stick free phenomenon. Stick free, that is no sticking. Stick free phenomenon with the help of tersite coatings. So in case of ball screws, your conventional square threads and acme threads are replaced with a special kind of thread profile in which you have balls, and in which we have balls. Sir, lecture मध्ये नंतर फोन करू. In which the balls are fitted and they are preloaded, and they are preloaded. So you get zero friction. You get zero friction. This is how your ball screw will look like. This is the screw. Look at the profile. Look at the finish. Then these are the balls. which moves inside the groove, and you are preloading this assembly. Preloading means you are adjusting the clearance between this nut and the screw. How do you do that? Preloading, you apply a force from outside. You apply a force from outside so that the clearance is reduced. If you apply more force, then clearance will be less. Still more force, less. There has to be very little clearance. Understand? You cannot have zero clearance, because if there is a zero clearance, there will not be movement at all. Understand? No? So there has to be very small clearance. At the same time, you have to see that the clearance is not much also. If the clearance is much, then there will be a play, dugu dugu. Understand? No? So you will not get proper movement, proper positioning. This preloading is factory set. Factory set means there are special machines, SPMs, for preloading. So before dispatch, they preload your system, that is screw and nut, and then inspect, take the cuts, and then only dispatch. Generally, we don't do this preloading in house. This is the linear motion guideways. See, these are the guideways, and linear motion means it will move longitudinally. Anti friction means no friction. See, theoretically we say no friction, but practically there will be little friction. But the value of mu is as low as possible. The advantage of linear motion guideways is very high rigidity, low friction, and less wear and high accuracy. Again, this is ball screw kind of motion. This is something from control engineering. This is for the closed loop control system. So you have to have a feedback in your system, and that is what is called the position feedback. So if you are programming say x 60.00, then constantly there has to be a check whether that 60.00 has achieved or not. So that monitoring is done by positioning feedback, and this is the circuit for that. You have a comparator here that will be called as a comparison. Like you have a command position. Command position means what command you are given. Let's say x60, and then this is a position feedback. Like say you have achieved a position of say x55. That means there is an error of 5 mm. Still 5 mm it has to go. These small errors are amplified. This is a symbol for amplifier. You have to follow these symbols. These small signals are amplified, and then it is given to the velocity comparator. Like now 55 hai, I have to go 5 mm. So how to change the velocity? Whether to change the velocity in x direction or y direction or z direction or in all. So again those small signals are amplified because the motors needs 32 amperes, 440 volts. This is electronic circuits. Remember, most of the electronic circuits, the maximum voltage developed is 12 volt. That is your diodes, transistors, ICs. It doesn't require more than 12 volt DC. Whereas 12 volt DC. Whereas we are talking about servo motors to drive the machine. We are talking about 440 volts. Talking about 32 amperes. All right. So then the motor runs. and this motor will drive the machine tools. So there has to be a connection between this. On the shaft of the servo motor, at one end, a tacho generator is fitted, which gives constantly the feedback, velocity feedback. That is, whether the desired position has been achieved or not. Either you can use encoder or you can use tacho generator. If you want to measure the velocity, then you have to use tacho generator. If you want to measure the RPM, that is revolutions per minute, then you have to use encoder. That is why this has been shown dotted. Alright, like say 100 RPM. So I want to ensure whether 100 RPM has come or not. So that time encoder will be used. Tacho generator, let's say I have given a cutting speed of say 100 meters per minute. So meters per minute is nothing but a velocity. So that velocity will be checked by the tacho generator. And on the machine tools, we have some kind of a linear scales. This is a linear scale which actually measures the position. These are specially designed glass scales. And from here, the position of the table, whether it is 55, whether it is 57, 58, is measured and that signal is given here. So say 57.5, command position is 60, so there is a difference of 2.5. So like that it works. This is how encoder will look like. As I said, the encoder is mounted on the spindle, isn't it? And it is used for measuring the RPM. Alright. So there are slots cut. This is the disc. There are slots cut, slotted hole, slot cuts in the disc, which is embedded in the encoder. This is for the optical or rotary encoders because the light is passed or not passed. So whether the light is passed or not passed, and that is counted. And based on that, your RPM is measured in a simple way. So these slots will allow the light. Of course, there is a source, a light source, and this is inside the encoder, and encoder is mounted on the spindle, and obviously there is a light source. So number of lights or flashes is counted, and accordingly your RPM is measured. That is actual RPM is measured. Alright, this is what your encoder is, which is used for measuring the RPM. This is how. This is what is your servo motor is. Servo motor is connected to the lead screw. And remember, there is a mistake here. There is no lead screw. You have to have a ball screw here. So motors are connected to the ball screw. Other end of the ball screw, we have encoder here. Then on the machine control, you have linear scales or glass scales that gives the position. And this is how the circuit is completed. So there is always a comparison happening. Encoder will count the RPM, positional feedback will count the position of the machine, and accordingly the spindle will be rotated. Like if the pitch of the ball screw is say 1 mm and the current position is say 55 mm, I repeat, if the pitch of the ball screw is say 1 mm, command position is 55 and the commanded position is 60. That means it is sensed. There is an error of 5 mm and the RPM is how much I said, sorry, the pitch is how much I said 1 mm. So how much more rotation is required? It has to move 5 mm more, isn't it? 60 minus 55. So that is 5 mm. And the pitch is 1 mm. So the encoder and the servo and the feedback circuit will give an instruction that spindle has to be rotated 5 more times. That is 5 more revolutions has to happen. Why 5 more revolutions? Because in one revolution it will travel 1 mm and 5 mm more has to be moved. So the braking will occur after rotating the spindle after the revolutions of 5 mm. So this is how it works. Again the same diagram, that is the previous diagram and this diagram, the optical scales are shown here. That's the only difference. But you can draw this diagram in your exam. You can draw this diagram, very simple. And if required, if you want 5 out of 5, then you can draw this diagram also. There are some more feedback devices like we have, scanning, but we don't use this. These are purely based on interferometer technology. Most of the CNCs they follow, or I will say 100% CNCs they use encoders or tacho generators. If you are, you can refer this book, P and Raw. Any doubts, please feel free to ask. Yeah, Sachin, Indrajit. Hello, Indrajit. Are you there or not?
Yes, sir.
Any doubt? I
No,
doubt.
sir. None.
Sure.
Yes, sir.
Can you see this slide? Hello,
No, sir.
Indrajit. Can you see this slide?
No, sir.
No.
No.
Yeah. Now,
Yes, sir.
Indrajit. Yeah. Can you read it?
CNC Hardware.
Good. It is visible, no? Clearly. Yeah.
Yes, sir.
So just a continuation. I again uploaded this also in the classroom because the weightage for this CNC hardware is 5 marks. So either they will ask on the structure or on the spindle or on the encoder or ball screw. 4 to 5 hardwares you have to study. You know the we'll quickly go through this. You know the functions of the spindle. These are rotating. They provide position and transmit the power to a tool. They hold cutting tools. They have to give high torque and speed. Then it should cut variety of materials. Then it holds a rotating workpiece, that is in case of lathes, and it holds a tool, that is in case of machine. So the principle is that it should give a good power, should give a good torque, should be durable, you should get good quality, That is, we are talking about 1 micron or half a micron. Earlier, I showed you the photograph in last presentation. Now here, this is a cross-sectional view. You can draw this easily, isn't it? So you have roller bearings and you have ball bearing here. All right. From here, you get a drive either from a motor or geared, and then this side you are holding your workpiece. HMC is nothing but the full form of HMC is horizontal machining center. The difference between machining center and milling is in milling there is no tool magazine. The number of tools which can be hold is only one. Whereas in case of machining center, you can have or you have tool magazine which can hold 20 tools, 40 tools, up to 120 tools. Normally 40 tool magazine is common in most of the machining center. Machining center can be horizontal or can be vertical. Vertical machining center means like your vertical milling machine. The spindle is vertical. Horizontal machining center means the spindle is horizontal. See, two pillar structure. So two pillar structure will give you a good rigidity. If the machine is vibrating, that means gone. You will not get any accuracy. Again, if you want to avoid the deflection in case of vertical machining center, then you have to go for C type construction, which I showed you in the last PPT. You go for C type construction. This is how your spindle will look like. From here, you are getting drive from the motor this side. This is for the rear end. This is what is your front end. You can see this threading. These threadings on these threads, we are mounting chuck in which your workpiece is hold. These are the bearings. These are the bearings. And this is your pipe in, that is coolant in order to cool the spindle. So you have to see that chips and coolant doesn't go inside the spindle. Otherwise, it will spoil the spindle. The chips will go or it will cut the shields of the bearing and it will damage the bearing. Once the bearings are damaged, then your spindle will run eccentric or spindle will run out. And once the spindle is out, then you have to replace the spindle or the machine accuracy is gone. Same thing is coolant. If the coolant is going inside the spindle, then for a period this coolant will have a corrosive action on the spindle. So your spindle will get corroded from the inside and again accuracy is lost. So you have to have a air purging system, you have to have wipers, you have to have good pressurized system, you have to have a lubrication system. So all these are the functions of CNC design engineer. Spindles can be classified as belt driven, gear driven, motorized or integral motor means the spindles are directly connected to the motor and high frequency spindles. Generally, we are here, that is gear driven spindles. 99% CNCs they have gear driven spindles because belt will have slip, will not have proper or good torque, will not transmit the power properly. Only the advantage of belt is if the distance between the motor and the spindle is more, then belts are preferable. But nowadays we maintain the distance in such a way that spindles can be driven by gear, and gears are positively driven, good torque, no slip, good power, etc. etc. These are some advantages and disadvantages. That is, it is less expensive. Power and rotations can be given with the help of an external motor. That is, motor can be situated outside. Like I was talking about the slip of the belt, which can be overcome with the help of a cogged. Cogged means having a tits on the belt. Those who are working on the projects, they must have used this cogged belt. Means the belt has tits from the inner side, and the belt which is mounted on a pulley, that pulley also has tits. It looks like a gear, but not gear exactly, because the depth is less. Or you can have V belts also, two V belts or three V belts. Cogged belts are preferred, but definitely in terms of speed, power, torque, geared drive are always preferred. Gear drive. It can give you good torque, high torque. It is also useful for low speed operations also. It is desirable, gives good rigidity, speed variations, and so on. Integral spindle motor, like now here, we have a motor, and then the drive is transmitted to the belts, to the pulley, and this is your spindle is. In case of integral spindle motor, your spindle is directly mounted on the motor. So there is no transmission loss, very compact, but this design can be used only up to low power applications, maybe up to 2 HP or 3 HP. So if you want high material removal rates, then integral spindle motor design is not applicable. Of course, the design is also complicated. From academic point of view, you can definitely study if you are curious academically. Examination point of view, it is not important. Your spindle is directly mounted inside the motor. That is what is your integral spindle is, or your motor output shaft is designed in such a way that your chuck, that dish chuck, or your faceplate can be directly mounted on the motor output shaft in a simple way. This is what is your integral spindle means. High frequency spindles are very common in terms of precision, higher speed, and productivity. Not only that, you also get good surface finish and closer tolerances. As I have been telling again and again, in CNCs, the drives, spindle drives are also called as the PIV, or axis drives are also called as the PIV, that is positive infinitely variable. You get any speed in terms of decimals, and that is only possible because of this DC servo motors. Last presentation we saw that you have to maintain the spindle temperature, so there has to be good cooling arrangement. At the same time, adaptive control we were talking about. They have temperature compensation system in adaptive control system. So the temperature compensation system means if the temperature of the spindle increases, then it compensates for that rise in temperature. That is what is your temperature compensation system is. So you have you have different parameters for choosing the spindle, power, then load, what is axial load, what is radial load, size, weight, torque, etc. etc. To go a little fast because we have to complete this. Then axis drives. It drives means it can be spindle drive or it can be axis drive. So clearly it will be asked in the question. Describe spindle drive or describe axis drive. So the motion in a CNC can be automatic. It has to be precise and consistent. Precise means it has to stop at that point, and consistent means repeatability. That it should repeat same position every cycle or continuously, not only once or twice. So that repeatability or consistency or uniformity is very important in motion control. So you have motors, you have ball screw, you have encoders, you have linear scales, and you have tacho generator. This is what we have seen, isn't it? Never talk about lead screw in CNCs. You have to always speak about ball screw. No lead screw, no rack, no pinion. So only ball screw, encoders, and linear scales.
Rani sir, let us
Yes,
conclude.
yes, please.
Let us conclude the incident.
Loudly, I cannot hear you.
Rani
Hello?
sir,
Yeah?
hello. Sir, let us conclude.
Let us.
Conclude.
Hello? Speak loudly. I can't hear.
Can we conclude this
Hello?
lecture, sir?
Yeah, just to give me 2 minutes. Huh? Huh? 2, 3 minutes. Fine?
Okay, thank you, sir.
Yeah. Just hold on. Huh? You can go through also this. I'll just touch upon this. Huh? So you have, movements in x-axis, y-axis, and z-axis. That is what is called as the control of various axes. This also I have explained in last presentation. Additional axis can be this, that is rotary axis. So we have machines up to 7 axes. This is how a feedback system looks like. You have a table having a nut and ball screw. You will understand this very easily. This is a good diagram, and you can draw this also. And open and closed loops. This is your closed loop. In closed loop, the feedback is given like this, and in open loop, there is no feedback. Open loop machines are less costlier. Closed loop machines are costlier. And similarly, different type of motors are used to feed drives, brushless, AC, stepper, and linear motors, which we have discussed. And go through this. I have given jump start so that you can understand this. It's not that difficult. I also explained you what is stepper motor, what is servo motor. Servo motor means good positioning. It will work pulse by pulse. You have been given the comparison of servo motors and stepper motors also. This is important from your examination point of view. So the comparison is in terms of cost, versatility, reliability. Always servo motors are better in terms of sizes, complexity, life, torque, repeatability, and safety has advantage. Stepper motors are economical. Linear motors means it will give motion in linear, that is reciprocating. Actuation systems also we have discussed, that is ball screws, then slideways. So these are the ball screws. It has less friction, longer life. Looks like this. You have balls. This is recirculating, that is the balls are moving continuously. Then linear motion, guideways, that is reciprocating movement of the beds we discussed already, and feedback devices also, encoders and tacho generators we have discussed. Encoders there are two types, that is optical rotary and incremental types. But you can only talk about absolute, you can only study absolute encoder. If you want, you can study the difference between absolute and incremental encoders. So thank you very much. So I'll summarize. So today we studied hardware, that is structure, wall screw, encoders, tacho generators, linear scales, what are the design criteria. Then there are two types of encoders, that is rotary encoders are two
Sir,
types, that is incremental and absolute.
sir,
This is what we studied. Yeah, please, Bolo Niraj.
sir, we have a
Yeah,
break now. Can we conclude,
so loudly.
please? Sir, we have a break now. Can we conclude?
Yeah. No, I'm just summarizing, and you can take your leave. So what I was telling, you can hear, no, Niraj? Hello,
Yes, sir.
hello. Yeah, I was just summarizing that we studied ball screws, we studied encoders, we studied tacho generators, then servo motors, stepper motors, and structure in the hardwares. If you have any doubt, you can ask. Otherwise, uh, you are most we can stop it. Nothing in the chat box.
Thank you, sir.
Yeah. Any
Thank you, sir.
doubts, Indrajit?
No, sir.
Yeah, neither you have any doubts.
Thank
You
you,
will go for
sir.
No,
breakfast.
sir.
Huh? All right. Okay, you may leave. Thank you.
Thank you, sir.
Yeah, thank you.
Thank you, sir. Thank you, sir.
Yeah, most welcome. Yes, Sonali, you want to say something? Hello? All right, thank you guys. I'll take your leave.